Have you ever questioned whether death is simply an illusion, a quantum phenomenon we are still trying to understand? Unveiling this enigma takes us deep into the realm of quantum mechanics, where our understanding of reality starts to bend and distort. Let's delve into a theoretical experiment known as quantum immortality, an idea rooted in the many worlds interpretation of quantum physics. Picture this: every conceivable event transpiring within its own distinct universe. That's right, an infinite number of parallel realities stacked atop each other, each representing a different outcome of existence. Think about this for a moment. If you were to meet your demise in one universe, you would persist in another. In this context, death becomes not a termination, but a transition, a shift to a different reality. This hypothesis redefines our comprehension of life, death, and existence itself. Let's now consider some scientific perspectives on this. As per Neil deGrasse Tyson, the renowned astrophysicist, quantum immortality is currently more of a hypothesis than a theory, lacking empirical evidence. However, he acknowledges its fascinating potential implications for our understanding of life and death. The late Carl Sagan, an influential scientist and science communicator, often discussed the many worlds interpretation, alluding to the possibility that our reality is but one of countless variations. Dr. Brian Greene, a theoretical physicist and string theorist, takes this one step further. He suggests that quantum tunneling, a phenomenon where particles overcome barriers that classical physics deems impossible, could possibly be a mechanism for quantum immortality. In essence, death could potentially be a passage to another existence, another reality. Intriguing, isn't it? This concept not only challenges our understanding, but also extends an invitation to explore the profound depths of the quantum universe and its myriad complexities. Now let's shift our gaze to another fascinating phenomenon that defies our everyday logic: quantum tunneling. Quantum tunneling is a phenomenon that seems to hail straight from the realm of science fiction. In the classical world, it would be akin to a tennis ball, suddenly disappearing from your hand and reappearing on the other side of a solid wall. Yet, in the quantum world, this is an everyday occurrence. To understand quantum tunneling, we first need to grasp the idea of quantum particles. These particles, unlike their larger counterparts, are not constrained to one location. Instead, they exist in a state of superposition, meaning they could be in multiple places at the same time. This is where the concept of a barrier comes into play. In the quantum world, a barrier is not an impenetrable wall, but more of a hill that particles may or may not have enough energy to climb. Here's where quantum tunneling comes into the picture. Even if a particle doesn't have enough energy to surmount the barrier, it can sometimes still make it to the other side. It's as if the particle borrows energy from the universe, tunnels through the barrier, and then pays it back, all in a fraction of a second. This act of borrowing and returning energy is what makes quantum tunneling possible. Quantum tunneling plays a vital role in many natural processes. For instance, it's at the heart of nuclear fusion within stars. Without tunneling, the protons in the sun wouldn't have enough energy to overcome their mutual repulsion and fuse together, and the sun wouldn't shine. Similarly, quantum tunneling is responsible for radioactive decay. This strange phenomenon challenges our everyday understanding of reality. It tells us that the world at the quantum level operates under a different set of rules, where barriers are not absolute, and particles can exist in multiple places at once. Quantum tunneling, an enigma wrapped in the mysteries of quantum mechanics, opens doors to a world where the impossible becomes possible. You might wonder what connects these two concepts, quantum immortality and quantum tunneling. At first glance, they might seem poles apart, yet they're intricately woven together by the threads of quantum mechanics, the very fabric of our reality. Both concepts push the boundaries of our understanding, challenging our perception of the world. Quantum immortality, a thought experiment that explores the idea of endless existence, and quantum tunneling, a phenomenon where particles pass through barriers as if they were mere illusions. Both are grounded in the peculiar principles of quantum mechanics. These concepts encapsulate the bizarre and counterintuitive nature of the quantum world. A world where particles can exist in multiple places at once, where causality can go on a holiday and where the observer influences the observed. It's an awe-inspiring, mind-bending reality that leaves us with more questions than answers. Quantum mechanics, with its immortality and tunneling, paints a picture of a universe far more complex and fascinating than we could ever imagine. To wrap up our quantum journey, let's revisit the key points we've explored today. Quantum immortality, a thought experiment that stems from the many worlds interpretation of quantum mechanics, suggests that we might be living in a universe where death is not the final frontier. It's a concept that both fascinates and challenges our understanding of existence itself. Moving on to quantum tunneling, this phenomenon allows particles to pass through barriers that should, according to classical physics, be insurmountable. It's like walking through a solid wall in the world as we know it. Impossible, right? But in the quantum realm, the impossible becomes possible, and particles can tunnel their way through barriers, defying our everyday understanding of how the world works. These concepts remind us of the strange and fascinating nature of the quantum world, a world that continues to challenge our perceptions and understanding of reality. As we continue to explore the quantum realm, one thing remains certain: there is much more to our universe than meets the eye. Until next time, keep questioning, keep exploring. Quantum mechanics invites us to question everything we know about our universe. It's a realm where the impossible becomes possible, and the improbable probable. As we journey through the quantum realm, we're left with more questions than answers. But isn't that the beauty of exploration? The thrill of the unknown? The excitement of discovery? Our journey today into the quantum world has been a glimpse into the vast and fascinating mysteries it holds. We dove into quantum immortality and quantum tunneling, two concepts that challenge our understanding of reality. Yet these are just the tip of the quantum iceberg. There's so much more to uncover, to question, to understand. Thank you for joining us on this journey into the quantum realm. We hope it sparked questions, ignited your curiosity, and inspired you to explore further. We encourage you to keep questioning, keep wondering, and keep exploring the mysteries of the universe. Don't forget to subscribe and hit the bell icon for more intriguing videos like this one. Let us know in the comments what kind of space and quantum mysteries you'd like us to unravel next. Until then, keep your curiosity piqued and your mind open to the wonders of the quantum world. Until next time, keep exploring. Before we wrap up this quantum journey, we'd like to remind you to like this video and subscribe to our channel. Your support helps us continue our exploration into the fascinating realms of science and allows us to keep bringing you videos like this one. Remember, each like, share, and subscribe fuels our journey deeper into the mysteries of the universe. So, don't forget to hit the bell icon and the like button to stay updated with our latest videos. It's your passport to the quantum world and beyond. Until next time, keep your curiosity alive, your mind open, and as always, keep exploring.